6.1 Solving linear systems by graphing. When we are solving systems and we graph, where those two lines intersect on our graph is our solution. So if we look at some examples, like example A, they give us 2x plus y is equal to 6 and negative x plus y is equal to 3. So if we solve both of these equations for y, we'll put them in slope-intercept form, and then we can graph based off our y-intercept and our slope. So for the first, we have 2x plus y is equal to 6. We're going to move the 2x over by subtracting it, and we get y is equal to negative 2x plus 6. So we have our first point, that's 6. Then we have our slope of negative 2, so that means we're going to go down 2 to the right 1. Down 2 to the right 1. Now, the reason why I'm doing this in your video and not in your notes is because with this video, I can't draw a straight line. So I want to make sure that I have all of my ordered pairs throughout all of my graph, so that way I can see exactly where these two lines are going to intersect. So that's my first line. My next line, we have that negative x plus y is equal to 3. So I would add the x to both sides and get y is equal to x plus 3. So we have our first point of 3. Then we go up 1 to the right 1, up 1 to the right 1, and keep going throughout the entire coordinate plane. And same thing with the opposite way. So if we see here where these 2 points intersect is this point here that's in blue, which is the ordered pair 1, 4. So our solution is 1, 4. For our next example B, we have y is equal to 2x minus 2. This line right here is in slope-intercept form, so we are just going to graph the negative 2 for our y-intercept and then use our slope of 2, so up 2 to the right 1. Again, when you do your homework for this section, it's going to be a lot easier to just draw the two lines or draw the 2 points and then draw your line through those 2 points. Because like I said, when I do this, it's not going to be a straight line. So it's not going to be perfect. With your next line, you have 3y plus 6x is equal to 18. We're going to move the 6x over by subtracting it from each side. We get 3y is equal to negative 6x plus 18. Then we divide each side by 3 to get y is equal to negative 2x plus 6. So we're going to start at 6 and then go down 2 to the right 1, down 2 to the right 1, down 2 to the right 1. We see here that even though this line is not going to be perfect, we do have our solution here, which is the ordered pair 2, 2. For example C, we have 2x minus y is equal to 8. We are going to move that 2x over by subtracting it from each side. We have negative y is equal to negative 2x plus 8. Divide each side by negative 1. We have y is equal to 2x minus 8. So we're going to start at negative 8. We're going to go up 2 to the right 1. And then also down 2 to the left 1 to get those extra points. All right, so for our next line, we have x plus y is equal to 1. Subtract that y from each side, we get y is equal to negative x plus 1. So we're going to start at 1, and then we're going to go down 1 to the right 1, and keep going down 1 to the right 1. So this is going to give us our line that looks similar to this. And then our point of intersection is the ordered pair 3, negative 2. For D, we have y is equal to negative 2x minus 2. So we're going to start at negative 2. Gonna go down 2 and to the right 1. Oops. And then up 2 and to the left 1. So just opposite. For the next line, we have x plus 2y is equal to negative 2. Oops. X plus 2y. X plus 2y is equal to 2. So we're going to get that y by itself. We're going to subtract x from each side. We have 2y is equal to negative x plus 2. Then we divide each side by 2. And we have y is equal to negative x. Oops. Negative 1 over 2. Negative 1. Oh my goodness. Over 2x plus 1. So from here, we're going to go to the 1 on our y-axis, plot our first point, then go down 1 to the right 2. 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 To the right 2. There we go. And then we're going to also go up 1 to the left 2. Up 1 to the left 2. And then keep it going for your whole coordinate plane. When we draw the line through these points, our point of intersection is right here, which is the ordered pair negative 2, 2. For our next one, we have y is equal to negative 2x minus 2. So we're going to start at negative 2 and then go down 2 into the right 1. Make sure it goes through our whole coordinate plane. And then up 2 to the right 1. So we're just going to keep going here. Make sure it goes through the entire thing. And we'll try to draw the straightest line we possibly can. There we go. Alright, so for our next one, we have negative x plus y is equal to 6. We're going to add the x to both sides and get y is equal to x plus 6. From here, we are going to go to that 6 on the y-axis, plot our point, and then use our slope of up 1 over 1, up 1 over 1. And then down 1 to the left 1 as well. So if we see our point of intersection here, it is literally right in the middle of two numbers here. So our x is going to be negative 2.5, and our y is going to be positive 3.5. If we look at the next section, we're solving special systems now, which means they could either be the same line or they could be parallel lines, and they do not intersect at all. If they are the same line, our answer is all real numbers. And then if it's two parallel lines where they don't intersect at all, then our answer is no solution. So if we do our first line here, we are going to do negative 2 on the y-axis and then go up 2 to the right 1, up 2 to the right 1. Do that for the rest of your coordinate plane, going to the right and the left of the first point, and then draw your line. For your second line, you have negative 2x plus y is equal to 4. We're going to add the 2x to both sides. So we have y is equal to 2x plus 4. So our slope is 2, our y-intercept is 4. So we're going to start at 4, then we're going to go up 2 to the right 1. You'll realize that these two lines have the same slope, which we remember means that they are parallel to one another. So they will never intersect. So since they never intersect, our answer is no solution. For our next one, we have x minus 2y is equal to negative 6. So we're going to move the x over by subtracting it. Oops. Then we have negative 2y is equal to negative x minus 6. We are going to divide each side by negative 2. This is going to give us y is equal to 1 over 2x plus 3. So we're going to start at the 3, go up 1 to the right 2, up 1 to the right 2, and keep it going for the whole coordinate plane. Draw your line through your points, and then move on to your next slide. Your next one, we have x minus 2y is equal to 2. We're going to subtract the x from each side. Negative 2y is equal to negative x plus 2. Then divide by negative 2 on both sides. And we're going to get y is equal to 1 over 2x minus 1. So we'll start at negative 1. Use your slope. Up 1 to the right 2. Up 1 to the right 2. Keep it going for the whole coordinate plane. Draw your line through them. You'll realize that these two lines once again are parallel. So because they are parallel, we have the answer of no solution. For our next example, we have y is equal to 2/3 x minus 1. So we're going to go to negative 1. Then we're going to go up 2 to the right 3. Oops, that's 1. Up 2, there we go, to the right 3. Up 2 to the right 3. 2 to the right 3. We can also go down 2 and to the left 3 for this as well. So we would get it throughout our entire coordinate plane. Draw your line through those points, and then move on to your next. We have negative 2 over 3x plus y is equal to 1. So we're going to add the negative 2 over, add the 2/3 x to both sides. So this gives us y is equal to 2 over 3x plus 1. We'll realize that these two are the same exact line, so it's literally going to be right over each other. So because they share the same exact points, we have all real numbers. You can also give me this for your answer. So the symbol for all real numbers is fine as well. For D, we have y is equal to 3x minus 3. So we are going to start at the negative 3 on the y-axis. Go up 3 to the right 1. Keep going up 3 into the right 1. Or down 3 into the left 1. Here we go. Alright, so draw your line. And then move on. So then we have negative 3x plus y is equal to negative 3. Add the 3x. So y is equal to 3x minus 3. These are the same exact lines, same exact equations, so we have all real numbers for our answer. For E, we have 2x plus 3y is equal to 6. I'm going to subtract the 2x from each side, so 3y is equal to negative 2x plus 6. Then divide by 3. We have y is equal to negative 2 over 3x plus 2. Now, I want to solve my other equation first just to see what it's going to give us for the equation. So with this one, I would subtract the 4x from each side. I get 6y is equal to negative 4x plus 12. And then I'm going to divide by 6 on each side. So I have y is equal to negative 2 over 3x plus 2. So my equations are the same. So when I graph these, we're going to have 2 starting with, and then down 2 to the right 3. Or up 2 and to the left 3. So these lines are actually going to just go right over each other. So we have infinitely many solutions, which you can write that as well for your answer. For f, we have y is equal to negative x minus 2. So for this one, we're going to start at negative 2 on the y-axis and then go down one to the right one for the entire coordinate plane here. And then draw your line over your points. For your next line, solve for y. So we're going to subtract the x, we're going to subtract the 2. So we have y is equal to negative x minus 2. So we're going to have the same slope here, same y-intercept. These ordered pairs are going to be the same as the first line, so we have infinitely many solutions.